Okay, so just like when we were doing imperfect squares, we had irrational numbers. Cubes are the same situation. Only perfect cubes will give you those nice, pretty whole numbers. Everything else is going to be considered irrational. And remember, irrational numbers can't be written as a fraction, and they have those long, crazy, crazy decimals. So to actually figure out what those are without a calculator who can tell us what that long string of decimals is, we need to estimate each number. So we need to figure out the numbers that it falls in between, and then maybe estimate a decimal here and there, depending on the question. We're gonna do the same sort of thing we did with square roots. So we're gonna make a number line with everything that we use, and then we're gonna find the cube roots it falls in between. The only difference is we're doing the cube roots. So you start with the regular numbers. And that would give us 1 cubed was 1, 2 cubed was 8, 3 cubed was 27, 4 cubed was 64, 5 cubed was 125, 6 cubed was not 36, it's getting mixed up there, it's 216, 7 cubed was 343, 8 cubed was 5. We can use our chart when we forget, like I just did for a second. 8 cubed was 512. 9 cubed was 729, and 10 cubed was 1,000. So just like yesterday, we're going to find the number that this falls in between. So we want to find where the cube root of 21 falls in between all of these cube roots. Remember to include your 3 at the top of your radicals. Well, the cube root of 21 falls somewhere between the cube root of 8 and 27. So the two integers it falls in between are 2 and 3. That's all you have to do. I look for the numbers at the bottom part of the number line that we created, and then just say what two positive integers it falls in between. So it fell between the cube root of 8, which is 2, and the cube root of 27, which is 3. The next one is determine which two positive integers the cube root of 350 falls in between. Well, the cube root of 350 falls in between 343 and 512 here. So that would be between 7 and 8. I know that that's all I have to do because it asked me what two numbers it falls in between. The extra step comes when they ask me to approximate it to the 10th. That means they want a decimal answer. So we still have to figure out what two numbers it falls in between. Then we have to take a guess at what the decimal might be. So the cube root of 900 falls somewhere between 700, the cube root of 729, and the cube root of 1,000. So it falls in between 9 and 10. It's closer to the cube root of 1,000. 900 is closer to 1,000 than it is 729, so that's the number it's closer to. So we have to think of a decimal that is in between 9 and 10, but's closer to 10. So the only numbers that can be in between 9 and 10 start with a 9 in front. So the numbers between 9 and 10 start with 9. There's nothing between 9 and 10 that would begin with 10. Now we need to think of a decimal to the 10th, that's one place after the decimal, that's closer to 10 than it is to 9. So that would be like a higher level decimal, like 0.8, 0.9. It's not too close to 10, it's still a little bit far away, so I would guess like 9.8. So when I say higher decimals, like what I'm thinking of is 9.1 is closer to 9. 9.8, 9.9, those are closer to 10. And then something in the middle would be like 9.5. So you're kind of basing it based on how far away your numbers are from the numbers that they're in between. And that's how we do the decimals. Okay, so let's do the practice questions. We'll use the same number line to help us. We'll fill that out. So you can use the same number line you already have written on your paper. I just rewrote it for you to have here. So we're going to do the same thing for the first three. All we have to do is figure out which numbers they fall in between. Well, the first one falls in between 27 and 64. So that means it falls in between 3 and 4. We don't have to say the decimal because it just asks what two numbers. The next one is 120, which falls in between, do that in a different color, 64 and 125. So it falls in between 4 and 5. It falls in between the cube roots of those numbers. The next one is the cube root of 250, which falls somewhere between the cube root of 216 and the cube root of 343, which is between 6 and 7, because that's the actual cube roots. So that's all you have to do for those that ask which two numbers they fall in between. The next one is where it gets a little bit more complicated. There's extra thinking you have to put in. First, you have to figure out which numbers they fall in between. Then you have to figure out which number it's closer to. So the first one is the cube root of 9, which falls in between 8 and 27. So that falls in between 2 and 3. But 9's a whole lot closer to the cube root of 8, so it's a whole lot closer to the 2 on the number line. We're comparing the cube roots to see which cube root it is closer to. So that means our decimal should be pretty close to 2 on the number line. I would say like almost 2, so 2.1 would work. So we know it's closer to 2 on the number line because the cube root of 9 matches closest to the cube root of 8. So we want a number that's between 2 and 3, but closer to 2. Cube root of 500, orange, falls somewhere between the cube root of 343 and 8, which is actually 512. I just kind of misprinted that. So because it's between the cube root of 343, which is 7, and the cube root of 512, which is 8, that's how we pick the numbers it's in between. So we need a decimal that's between 7 and 8. So we start with the 7. And then to decide the decimal, we need to decide, is 500 closer to 512 or 343? Well, I would say it's a whole lot closer to 512. So we need a higher decimal. We need a number between 7 and 8 that's closer to 8. So that would be like 7.8. The next one is the cube root of 4. Work that out. Different color. Cube root of 4 falls somewhere between 1 and 8. The cube root of 1, which is 1, and the cube root of 8, which is 2. So it falls somewhere between 1 and 2. Because it's a little bit closer to 4. It's a little bit closer to 4, but it's still like not that far away from 8. That's where we would pick a number sort of in the middle. It's 4 away from 8 and it's 3 away from 1. So it's a little closer to the 1, the cube root of 1. But it's not too far away from the 8. So that's when we pick like a middle level decimal, like a 0.4 or a 0.5. I would say 0.4 since it's slightly closer to the cube root of 1, which is 1. So essentially what you're doing is you're kind of guesstimating a decimal based on how close you feel it is in the number line. So I kind of guesstimated that the cube root of 4 would be somewhere close to the middle between 1 and 2. And a number that actually exists there would be like 1.4. So that's kind of how we're coming up with our ideas. Same thing, I kind of guesstimated that The cube root of 9 fell somewhere between 2 and 3, but it was a whole lot closer to 2, which is why we guessed it was like 2.1. So that's really what we're doing. We're going to talk a little bit more about the negative situations with cube roots versus square roots again. So this is like the big difference between them. There's a couple things you'll need to understand. First, we want to evaluate -4 squared and 4 squared and decide if they're both positive, both negative, or one of each. Well, -4 squared means -4 times -4, which is positive 16, because a negative times a negative is a positive, and 4 squared is 4 times 4, which is also positive 16. So they were both positive. So the question here is, do you think that the square root of 16 has 1 or 2 answers? Well, in the first situation, I multiplied -4 by -4 to get positive 16. So the square root of 16 can be -4, but it can also be positive 4 because positive 4 times positive 4 is 16. So there are 2 correct answers. One is positive 4, which we learned about yesterday, and the other is -4. But we don't always want to like write out the words. So actually when we take the square root of numbers, not the cube root, the number times itself, our answers will be plus or minus our number. That's how we would write those. So the square root of 16 is actually plus or minus 4. Let's see if the same logic works with cube roots, or let's see if it doesn't. This is -3 cubed, so we would do -3 times -3 times -3. -3 times -3 is positive 9. Positive 9 times -3 is -27. The next one is positive 3 times 3 times 3. Well, that's positive 27. So we got one of each in this case. I got a negative number and a positive number. So is that same logic going to work? Do you think that there's one correct answer or 2 correct answers for the cube root of positive 27? Well, when I did -3 times -3 times -3, I got a negative number. So that didn't give me positive 27. The only thing multiplied by itself 3 times to give me positive 27 is a positive 3. So there's only one correct answer. So my answer when I do the cube root of 27 can only be positive 3. So that's different. So there can be a negative answer to square roots, but there can't be a negative in a square root. And we'll talk more about that when we practice these and go through more examples with negatives. But essentially, square roots have 2 possible answers because there are 2 numbers you can answer to get a positive 16. But cube roots, there's only one possible correct answer. Okay, again, we'll talk more about the positive and negatives in class. We'll do some practice in class with all of this before we move on to the next thing. And this is all we have for this video today.